That may frustrate you for ages if you haven't done that. So the other thing we're going to do is to look at the characteristics using the summarize command. And last time what we didn't do was sort of unpack how STATA actually does this. STATA actually runs the calculations to get the mean, the standard deviation, and other calculations. So what I want to do today is start off by sort of looking under the hood to what's running when we run the summarize command. And the way to do that is to use the return list command, which is a new command. Again, we have all the commands listed in Appendix A of the handout, so you can refer back to them. But if you hit return list, you'll notice that a number of things happen. In order to calculate all of these things, STATA generates what are called scalars. Scalars are, just think of them as measurements, or sort of another name for them in STATA is called an R-class variable, because they start with R, and they tell you the class of variable they are. You have the total number of things in the sample, N. You've got the mean, R-class variable for the mean, the variance, standard deviation, minimum and maximum, and sum of all the observations. So they're pretty intuitive names, sort of abbreviations you always see in statistics classes, so that makes sense. But STATA does these calculations all the time.
What is sum W?
Sum W apparently is the total, I think it's the total number perhaps of observations over all the variables, but I'd have to look again.
It may be something about not including missing data or something like that.
Yeah, that could be. We'll find out soon, I think. Use another data set. So the reason I wanted to show you this is that the advantage of working in STATA and not just using a hand calculator is that STATA will keep all these decimal points and make your calculations much more accurate, which matters a lot if you're running regressions, doing addition, subtraction, whatever. STATA will keep this for you, so you don't have to type it in all the time. So what we're going to do today is to work with STATA using a lot of variable names to make sure that we hold the exact nature of the data, to make sure that our significant digits stay constant throughout all our calculations.
Can I ask one more question? What if you don't want to see all those digits? Isn't there a way to say only give me 2 digits after the decimal or something? Yeah,
we could round STATA. So there are several answers to that question. The first thing is that by default, STATA, when you import data, keeps 7 decimal places. You can specify more, you can specify less. There are also rounding figures you can use, and when you output to tables, not necessarily scalars, but tables and things of that nature, you can specify how many decimal places you want to see. So there are other options you can use for that. So this is what STATA does to calculate those things up there. So the other thing I want to show to you is that STATA runs these calculations each and every time you run a new command. So we've seen what the summarize command does. Let's look now what the count command does. So let's just consider, as you remember from last time with the logical operators, what happens if we just want to see how many mothers were 30 years of age when they gave birth in this 2002 data set. Count if, age mom, double equal sign, 30. The answer is in 2002, 2,180 mothers gave birth at the age of 30 in 2002. So again, let's look under the hood and see what STATA had to do for that. STATA had to only calculate the number of observations that met that logical condition. So there's only one scalar it returns here. What you'll have to remember is every time you do a new calculation, the R-class variables are erased, and a new set of R-class variables come in. So that'll become important in this next step. So this is the first time we're going to use STATA to do a calculation that isn't otherwise included in the data set. What I mean by that is we're going to use STATA's calculator function with these variables to begin sort of deriving things we want from the data set. So the first question, this is on page 3 of the handout, is a question about how we calculate with precision, which means with keeping all these decimal places, the fraction of mothers who are 25 years old who gave birth in 2002. How might we do that? I'm going to show you this first, and we'll sort of work into a more problem-solving mode the next time we do this. So the first thing to do is to think about what we want the numerator and the denominator of the fraction to be. So we're looking at mothers aged 25. We need a numerator and we need a denominator. The denominator for the fraction is going to be the total number of observations in the data set, because that's the total number of mothers who gave birth at all in 2002. The numerator is the number of mothers who were aged 25 who gave birth in 2002. So This is something I think just intuitively makes sense to you from sort of elementary mathematics. The trick now is to translate that into STATA speak. So I'm going to write it out here first, and then we're going to write in the commands. So the thing to notice is that we have to determine the numerator and the denominator separately, because they require separate R-class variables to be calculated. So the first thing to know is that this is an unrestricted sort of count function. To get the total number of observations in the data set, we've already seen it. It's 40,111. To do that, all we're going to do is to use a simple count command, which is going to give us the R-class variable R of n we want. The second thing we're going to do is use a restricted count command using the count if age mom equals 25. And we're going to get a different R-class variable for that. So what you'll notice here, and I want to emphasize this point again, is that the R-class variable is exactly the same name. It's R of n and R of n. So that means that you're going to have to be careful to make sure that you save this into memory as a different name before moving on to the second step. So let's break it down and see how that works in practice with STATA. It doesn't matter in which order you calculate the numerator and the denominator, but just to do the simpler thing first, let's just count out the denominator first. So, as I said before, let's just use the count command to give us the total number of observations in the sample. Here's the tricky part. To save this R-class variable into what's called sort of temporary memory, we're going to use a command called local. And we're going to be able to name this local variable whatever we want. So we don't confuse ourselves, we'll just call it local denominator. Because it's a new variable, it's a single equal sign. And what is that new variable equal to? Just like in the generic command, it's equal to whatever we want to make it equal to. In this case, the scalar R of n. Hit enter, it's been stored. Now we can safely know that we now have this denominator equal to the total number of observations in the sample. Let's move on now and do the second part to calculate the numerator. Count, as I said, just a restricted age function for all mothers who are age 25. Hit that, we've got 2,160. Let's make sure that it returned the correct scalar, which it always will. Yes, 2,160. Now, let's save it. Yes, Jamie?
Why do we want to check that it returned the correct scalar?
We don't need to. It always will. But I just wanted to sort of break down the process a little more to show you exactly what's happening so you can tangibly in your mind think of 2160 being slipped into the local slot. So, you're right, we don't need to. And I'll stop doing that after a while today.
Well, I have a question.
Yes, Christina?
When you were renaming the first count, the denominator, why didn't you have to do like save or generate? Why did you not need any other command?
That's a great question. Because R-class variables carry only one value and the local variable carries only one value. You can't have more than one observation. There's one slot. Basically what we've done, well, let me just go backwards and explain this. So the reason I was harping on the R of n thing is that R of n there's only one R of n which can carry one value per calculation. We created another variable called denominator which can only carry one value. Unlike a regular variable which has a variable which can have a range of values, local variables and R-class variables are not like that. They're what are called system variables, meaning the system uses them to calculate as you would with the memory function on a calculator, and then it erases it when you replace it with something else. So it's a very simple way to sort of move forward, but it also means that you don't ever need the replace command. And that's why you have to use generate, but instead use local.
Oh, so the command is local.
The command is local, that's correct. So I'll just assume that the first word of every command, and I will tell you when it's more than one word in a command, the first word in every command is what tells STATA to do something, and then what it operates on are the words following. So now we've returned the list, so now we have to create a new variable, so we don't confuse ourselves again. We'll just call it the numerator. Same way we created the denominator. So, if you recall, the way to use STATA's calculator function is to use display. And there's going to be something special about the way we use it this time because we're not using numbers, we're using variables with names that we've created. So display is, as you recall, the way to do variables. What you have to notice now is that we're going to use a single quotation mark, an entry quotation mark, which is next to the 1 key and the tab key on most everybody's keyboard. That's to begin the phrase. Numerator, because we're dividing from the numerator. And then now we're going to use